So in number 12, we're asked to find the inverse of x squared plus 3. But there's this odd statement following that for x is greater than or equal to 0. Now you may be asking, what is that? Why do they have that? So think about x squared plus 3. We look at the graph over here, and we know that the graph of f of x is equal to x plus 3 is a parabola that has been shifted up 3. However, this parabola fails the horizontal line test, because if I draw a horizontal line here, it's going to intercept that parabola in 2 places. So the reason they have included this is so the function will be 1-to-1. So this statement is saying we're going to find the inverse, but only for where x is greater than 0. So if we remove this part, now this function is a 1-to-1 function if we just look at the side of the parabola for which x is greater than or equal to 0. So that's why that part is included. So we have to consider this when we're talking about the domain of this function. So the domain of this function is going to be from 0 to infinity. All right, so now let's find the inverse of this function. So remember, we take the function and we replace f of x with y. Then we interchange the x's and y's. So we'll have x is equal to y squared plus 3. Now anything that doesn't have y in it is going to go to the other side. And I'm going to flip mine around again because I like what I'm solving for on the left. So I'm going to have y squared, these cancel, is equal to x minus 3. Now to solve for y, what we need to do is take the square root of both sides. So the square root of y squared is y, and the square root technically is plus or minus the square root of x minus 3. Now x minus 3, the square root of x minus 3, can be graphed. It's the radical function shifted right 3. So it looks like this, but the negative of that would be reflected across the x-axis and would look like this. That is not a function because it fails the vertical line test. So we're going to take off the negative part of this, and we're just going to say that the inverse is just the positive, the square root of x minus 3. So now I'll name this f inverse of x is equal to the square root of x minus 3. So we'll put a little note over here, removed. So the inverse is a function. What would the domain of this function be? The domain of this function is going to be from 3 to infinity. And I don't know if you remember, but when we were in class, we talked about, let me find that. Sorry, I'm going to make you dizzy for just a minute. But remember, we talked about this in class. When you have a function and its inverse, since they're the reverse mappings of each other, the domain of f is equal to the range of its inverse, and vice versa, the range of f is equal to the domain of its inverse. So if we go back to the example we were just working, notice that in our graph, the domain of this function was from 0 to infinity. What about the range? If we look up and down at just this graph here, the lowest point is 3 and it goes to infinity. So the range of f is going to be from 3 to infinity. Now, if we look at the domain of the inverse, it is the range of the original function. And the range of the inverse, well, if we look here and look up and down at just the red part, remember we took this part off, it starts at 0 and will keep getting bigger. So it's from 0 to infinity, which corresponds with what we talked about. The domain of the function becomes the range of the inverse. And we can go back to the other examples that we've worked. We did this one in class. I'm sorry, this one is the one we did on video. The domain of the original function is all real numbers. The range is also all real numbers, and that's if we're looking at just f of x. So I ran out of room, but I'm going to put it up here. And if that's true, then that should be the domain of the inverse, which it is. And the range of the inverse, well, that should be equal to the domain of the original function. What was I doing here? I should have put parentheses. I'm sorry. And of course, the range of this red line, well, it's going to go down forever and up forever, so it is all real numbers. The one we did in class was our rational function, and I didn't even talk about domain and range because I think I got a little busy. But without even looking at the graph, let's think about this algebraically. The domain of this function, remember that we take the denominator and we say it cannot equal 0, so x cannot equal -1. So the domain becomes from negative infinity to -1, union -1 to infinity. And if we look at this graph, we see a horizontal asymptote right here at x equals -1. And from what we learned in Unit 3, I'm sorry, that's a vertical asymptote. I'm sorry, I'm getting tired, guys. What we learned in Unit 3, that graph is never going to cross this vertical asymptote. And so that is the domain of the original function. Now let's look at the domain of our inverse. So remember, we're going to take the denominator, x minus 3, and say it cannot equal 0. So x cannot equal 3. So the domain of our inverse is from negative infinity to 3, union 3 to infinity. Well, if it's true what I said before, the domain of the inverse should be the range of the original function. Well, let's look at the graph for a minute. I'm going to try to box this in so it's apparent. If we're just looking at this blue function and we're looking how low and high it goes, I see a horizontal asymptote right here. And that corresponds with what we learned in Unit 3. The degree of the top is 1. The degree of the bottom is 1. So the horizontal asymptote, remember, that should be a y. I'm sorry, guys. Is y equals leading coefficient over leading coefficient. And in this case, that would be 3 over 1 or 3. So the range is going to be from negative infinity up to 3, union 3 to infinity. And that was the domain of our inverse. So using what we know about domains and ranges of inverse, we can say without even graphing that the range of the inverse is going to be the domain of the original function. So that's negative infinity to negative 1, union negative 1 to infinity. All right, so I hope this made sense for you guys, and we'll come back together on Tuesday, and you can ask questions if you have any.